Hello everyone, welcome back to our channel. In today's video, we will be discussing a new lesson. By the way guys, I would like to say thank you so much for all the subscribers and especially to my students and friends who helped me to let their friends subscribe my channel. So in today's video, we will be discussing on the computation, or you will be learning in computing probabilities corresponding to a given random variable. And we will also be illustrating the mean and variance of a discrete random variable, as well as calculating the mean and the variance of discrete random variable. So I hope that you will be enjoying in this entire video. So please bear with me and keep on watching, and let's get started. Welcome back to our channel. Now in today's video, we will be discussing about week 2 for quarter 3. So we'll start with the competencies for this entire week. So let's start with the day 1. So day 1, we are going to compute the competencies. Under day 1, we have here computes probabilities corresponding to a given random variable. And for day 2, illustrates the mean and variance of a discrete random variable. And for day 3 and 4, calculates the mean and the variance of a discrete random variable. Now the lesson objectives will start with day 1. At the end of the lesson, the students, or you are all expected to, under knowledge, you have recalls the following definitions of random variable, discrete random variable, and continuous random variable. I know that you already familiarized with these concepts based on our previous videos. And under the skills, computes probabilities corresponding to a given random variable. And under affective, we have appreciates the use of computing probabilities corresponding on a given random variable. And the use of the computing probabilities corresponding it's a typo error, so it just ends here. Again, under affective, we have appreciates the use of the computing probabilities corresponding on a given random variable. Okay, so let's start now. Computation and probabilities corresponding to a given random variable. Now, we were able to have this symbols already. You encountered the symbols already when you were still in your junior high and in your general mathematics subject in the first semester. So this time we're going to recall. You need to familiarize the inequality symbols. These are the inequality symbols and the meaning, as well as the word phrases. So for the symbol, this symbol, the meaning is less than, and under the word phrases, if you see fewer than and below, meaning that signifies this symbol. And this symbol is greater than, and it's also the same as more than or above. And for this symbol, it means less than or equal to. Under word phrases, you have your at most or no more than. And this one, this symbol, it means greater than or equal to. Under word phrases, you have at least or no less than. And this one, the last one, is not equal to. Okay, this is very simple, not equal to. Okay, there are two conditions of probability distribution. Number 1, each probability, P of x, must be between 0 and 1. That is, P of x is greater than or equal to 0 or less than or equal to 1. And number 2, the sum of all possible probabilities is 1, and in symbol, summation of P of x is equal to 1. Okay. So let's have an example. So observe the given examples from the previous discussion, tossing a coin twice. So there's an experiment. Is the kind of experiment that we're going to do is tossing a coin twice, and this is our sample space. Our sample space, we have TT or tail, then we have tail, head, tail, and then head, head. So let x be the number of heads that are observed. Then what have you observed? And what are the possible values that x can take 0, 1, and 2? Okay, so let's take a look at these possible answers. If x is equal to 0, that is tail, meaning no heads. And there is one possible outcome for x is equal to 0. For x is equal to 1, it means we have head, tail, and tail, head, meaning at least one head. And there are two possible outcomes that has at least one head. And the third one, if x equals 2, that means head, based on the sample space, that means two heads, and there is one possible outcome. Okay. Now, by definition, the probability distribution of a discrete random variable x is a list of each possible value of x together with the probability that x takes that value in one trial of the experiment. Okay, now let's try. So we have here, today we will be discussing how to compute the probabilities corresponding to a given random variable. Okay, let's have this example. Okay, so compute p of x. Compute p wherein x is greater than or equal to 1. So how are we going to answer that one? So we have here the table. You have here for x, frequency f, and then p of x. The x here we have 0, 1, 2, and the frequency is 1, 2, 1. And this is our p of x, or probability. We have 1/4 or 0.25. Remember, we got this table based on the experiment tossing a coin twice. And then having one head, we got two possible outcomes. So you have 2/4 or 0.5. And having two heads, we got one possible outcome. So you have 1/4 or 0.25. So if you are asked to compute if x is greater than or equal to 1, this is now the solution. Thus, p, or probability wherein x is greater than or equal to 1, is equal to p of 1 plus p of 2. Our p of 1 is 0.50. This one, 0.5. And our p of 2 is 0.25. So we're going to add a 2. So our answer would be 0.75. Okay, I hope that you're able to get how to solve this probability where x is greater than or equal to 1 based on the table. Now let's proceed. Now the following data show the probabilities of the number of laptops sold in a given day of certain tech computer store. Okay, so you have their number of laptops, x, and the probability p of x. From number of laptops is 0 to 10. And this is the probability p of x. Again, the following data, the table on the right, show the probabilities for the number of laptops sold in a given day at certain tech computer store. So let's proceed. So if we are asked to find p of x is less than p, find the probability of x that is less than or equal to 2. How are we going to answer this one? So if we are asked to find the probability of x where is less than or equal to 2, we are going to go back to the table. So this is our probability of when x is 2, and the question was find probability wherein x is less than or equal to 2. So there will be 3. So you will have p of 0. Okay, for a moment. So P of 0, which is 0.100, and P of 1 is 0.150, and P of 2 is 0.250. So we're going to add that one. So you will get this one. So the answer will be the probability where x is less than or equal to 2 is equal to 0.050 or 50 thousandths. Okay, let us proceed to letter B. What is the probability when x is greater than or equal to 7? So you have to analyze and understand properly the inequality symbol that is being used. So it says greater than or equal to 7. It gives us an idea that we're going to start at probability of 7 until the last one, which is 10. So P of 7 is 0.050, probability when x is 8 is 0.040, then P of 9 is 0.025, then the probability of where x is 10 is 0.015, a total of 0.130. So this is now the answer. How about this one? Find P, or the probability wherein x is greater than or equal to 1 but less than or equal to 5. That means we need 1 is included as well as 5 and the rest in between 1 and 5. So we're going to add probability wherein x is 1, that is 0.150. Probability wherein x is 2, that's 0.250. By the way, there must be a parenthesis here. Then P wherein x is 3 is 0.140. Probability wherein x is 4 is 0.090, and probability wherein x is 5 is 0.080. A total of 0.710 thousandths. Okay, so this is now our probability wherein x is greater than or equal to 1 but less than or equal to 5. Okay, I hope that you're able to follow. Next, let's have another example. So in a convenience store, the number of tellers X are busy with their customers at 9 a.m. So which varies from day to day. Past records indicate that the probability distribution of X is as follows. We have the number of laptops X and probability P of X. Okay. So we have here the answers. So what is the probability that exactly 4 tellers are busy at 9 o'clock or 9 a.m.? So P wherein X is equal to 4, we'll just look at the table. Okay, looking at the table wherein X is equal to 4, the probability is 0.212. So you get that answer, this one. Next, what is the probability that at least 2 tellers are busy at 9 a.m.? So that would be P is X is greater than or equal to 2. So you will have the probability listed from probability wherein X is 2, where X is 3, wherein X is 4, wherein X is 5, and X is 6. So these are the probabilities, corresponding probabilities. You have 0.078 plus 0.155 plus 0.212 plus 0.262 and plus 0.215, a total of 0.922 thousandths. Okay, so this is now the answer. Okay, let's continue. What is the probability that fewer than 5 tellers are busy at 9 a.m.? So it means to say fewer than 5 tellers. You have to, again, to analyze and understand the inequality symbol that we're going to use, meaning 5 is not included. So P of probability when X is less than 5, of course, you will start with P is of 0, then P of 1, P of 2, P of 3, and P of 4. You won't include 5 because there's no or equal to symbol here. So probability when X is 0 is 0.029. Probability when X is 1 is 0.49. Probability when X is 2 is 0.078. Probability wherein X is 3 is 0.155. Probability wherein X is 4 is 0.212. That's a total of 0.523 or 523 thousandths. Okay, let's continue. Now let us proceed to the mastery level. Give the probability of distribution, or given the probability distribution and random variable x defined as the number of good cell phones drawn from 5 cell phones, of which 3 are good ones and 2 are defectives, when 3 cell phones are drawn at random. Okay, so you have here the probability. Find the probability corresponding to a given random variable. First question, what is the probability of getting exactly 2 good cell phones? And then second, what is the probability of getting at most 2 good cell phones? Number 3, what is the probability of getting at least 2 good cell phones? Okay, so here's the answer. Okay, so we have here the number of good cell phones. These are the possible outcomes. Then the number of good cell phones, because x, a random variable x, is the number of good cell phones. So you have it there. And then we have the frequencies 0, 1, 2, 3. And then we are going to write it as our x, 0, 1, 2, 3. And our p of x will be 1 over 8. There is only one that will have, the outcome is 0. Then 1, 2, 3. We get 3 with outcome which is 1. And we get 3 with outcome is 2. And 1 when outcome is 3. Okay. So the first question was, what is the probability of getting exactly 2 good cell phones? Okay, so we are going to look at here. So meaning p, probability of x, where x is equal to 2, that's very simple. We're going to look at here. The x is equal to 2, the answer is 3 over 8. Next, what is the probability when x is less than or equal to 2? The question was, what is the probability of getting at most 2 good cell phones? At most 2 good cell phones, that includes 1 or 2. Okay, so that's p sub probability of 2 plus the probability of 1. That is 3 over 8 plus 3 over 8. That gives you 6 over 8 or 3/4. Next question. What is the probability of getting at least 2 good cell phones? At least 2 good cell phones. So you will have here, you have 3 over 8 and 1 over 8. So that is p of 2 and p of 3. Okay, so 4 over 8 or 3 over 8 plus 1 over 8, that gives us 4 over 8 or 1/2. So this is how you're going to answer word problems about probability distribution. Okay, let's continue. Okay, let's have an application. For example, some of the applications of probability distribution are predicting the outcome when you flip a coin. So you might be wondering where we're going to apply the probability distributions in real life. So you're going to apply by when you flip a coin, when you choose a card from the deck, when you throw a die, or pull a green candy from a bag of red candies and win a lottery. Okay. So what are the inequality symbols that are usually used in computing probabilities in random variables? I want you to answer this in your math activity notebook. Then how are we going to compute the probabilities given the random variables? Okay, now let's proceed to the evaluation. You're going to answer this one. By the way, for generalization and evaluation, that is where you're going to write your answer on your activity notebook. I mean, that is what you're going to write the answers on your activity notebook, as well as the assignment if you have. So answer the questions below. A discrete random variable x has the following probability distribution. Compute each of the following quantities. Letter A, probability of x when x is greater than or equal to 3. B, probability when x is 0. C, probability when x is greater than 0. D, probability when x is greater than or equal to 0. And E, probability when x is less than or equal to 2. Okay, so I hope that you can answer that one. So we can proceed to the next. And for your assignment, make a research and study the topic below, mean and variance of discrete random variable. Okay, well anyway, that's for day 1. Let us proceed to day 2. Okay, let's proceed to the objectives. At the end of this lesson, you are expected to identify the mean and variance of a discrete random variable, illustrate the mean and variance of discrete random variable, and develop patience and perseverance in illustrating the mean and variance of a discrete random variable. So start. Illustrations of discrete random variable. Okay, so we will have, so just imagine for this free activity. So imagine on your you're going to prepare 3 peso coins, or you can do that wherever you are right now. So prepare 3 peso coins, then toss the 3 peso coins 8 times, then record the number of heads on each toss, then get the average of the number of heads obtained. Letter A for the first 4 tosses, B for the first 6 tosses, and C for all the 8 tosses. Then you are going to construct a table. It would look like this. The possible outcomes, you have head, 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 the number of heads will be 3. You have head, head, tail, the number of heads is 2. Head, tail, head, the number of heads is 2. Then head, tail, tail, the number of heads is 1. Tail, head, head, the number of heads is 2. Tail, head, tail, the number of head is 1. Tail, tail, head, the number of head is 1. And tail, 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 there's 0 number of heads. So find the p of x and the product of x and p of x. So you will have another table after this possible outcomes. You will have your x as the number of heads, and you will also have p of x. Okay. So for the number of heads is 0, since there are 8, you toss the coin 8 times, you will have here the number of heads wherein the outcome is 0, then it's 1/8. Then number of heads that is 1, there is 3 possible outcome. 3/8. The probability, where the number of heads is 2 is 3/8, and the probability of that you will have 3 as the number of heads, you will have 1/8. Then afterwards, you got here, you multiply x and p of x. You will have 0 times 1/8, that's 0. 1 times 3/8, that's 3/8. Then 2 times 3/8, that's 6/8. Then 3 times 1/8, that's 3/8. Actually, this you can also write this one as 3/4 also. Then find p of x and the product of x and p of x. So this will be the total, 12/8, or equal to 1.5. Okay, let's continue. So we have here the formula for the answers. So we're going to look at the answers now. The questions first. So the question here was, what is the average of the number of heads obtained for the first 4 tosses? Let's check. Okay. First 4 tosses. So this is 1, 2, 3, 4. We are asked to find the average of the number of heads for the first 4 tosses. We are going to add 3 plus 2, that is 5, plus 2, that is 7, plus 1, that is 8. Okay, that's 8. And since you have here first 4 tosses, the number of heads is 8, then over 4. Next question. Okay, next question was the average of number of heads obtained for the first 6 tosses. Okay, first 6 tosses, let's count. 1, 2, 3, 4, 5, 6. Okay, we'll count. 3 plus 2, that's 5, plus 2, 7, plus 1, 8, plus 2, 9. Plus 2 is 10, then plus 1 is 11. And that is after 6 tosses. So you have 11/6, or that is equal to 1.83. And the last question, we have of all the 8 tosses, the average of the number of heads of all 8 tosses. So you will get, we're going to add all the number of heads here. You have 3 plus 2, that is 5, plus 2, 7, plus 1, 8, plus 2, 10, plus 1, 11, plus 1 is 12, plus 0, that remains 12. And this becomes 12 over 8. Okay, so the answer is 1.5. Okay, so from that second table, okay, take a look at the second table. We have here, what is the result when you multiply x and p of x? Okay, when you multiply x and p of x. And number 2, what have you observed of the results of the two tables above? Okay, or in the previous slide. So what is the result when you multiply x and p of x? What do you think? Okay, let's go back to the table. Okay, this is 1.5. So you should have seen that it resembled getting a weighted average of data with the probabilities serving as weights. Okay, so what have you observed the results of the tables? So you should notice that the average they got gets closer and closer to 1.5 as the number of values of the average increases. Now this is related to the concept of the mean of a random variable. If you've noticed, this is 1.5 and here also is 1.5. Okay, so this time let us extend our knowledge by defining the following terms. We have mean and variance, and by illustrating them. So what is mean? So the mean is considered as a measure of the central location of a random variable. Then it is a weighted average of the values that random variable x can take, with weights provided by the probability distribution. And the expected value or mean value of a discrete random variable x can be computed by first multiplying each possible x value by the probability of observing that value and then adding the resulting quantities. Now symbolically, we have here the summation of x is equal to, you've noticed that we use this symbol in our previous videos. We have that population mean. Okay, here we just use this as mean. This is equal to x sub 1 times p of x sub 1 plus x sub 2 times p of x sub 2 plus and so on and so forth plus x sub n times p of x sub n. Then the answer will be the summation of x plus p of x. Okay. Now let's have an example. Construct a probability distribution for rolling a single die and find the expected value. So we have 6 numbers in the die, then a single die 1 to 6. So you have this probability of x is 1 over 6 until 6. Okay, so if we're going to get the mean, this is how we're going to solve. Okay, the mean would be like this: 1 times 1 over 6 plus 2 times 1 over 6 plus 3 1 over 6 plus 4 times 1 over 6 plus 5 times 1 over 6 plus 6 times 1 over 6. And the resulting value of the mean is 3.5. Okay. So let's have the histogram on how it is presented in a histogram. So for a moment, so the resulting value of the mean is 3.5. So the average tends to be close to 3.5. This also implies that the more rolls we do, the closer the average will be to 3.5. Okay. So we have here the histogram based on this table, this one. If we're going to express it using the histogram, it looks like this. We have 1 over 6. And these are the die, rolling a single die with numbers 1, 2, 3, 4, 5, 6. Okay, and then our mean is 3.5, so that's why we have it here. Okay, we have 1 plus 3 that gives us 4, and then 4 plus 6 that gives us 10. And And then we also have 3 plus 4 that gives us 7. And between 3 and 4 we have 3.5. Okay, so you have it here. That's 4 plus 7 plus 10 over 6 is equal to 3.5. Or you can just simply add 1 plus 2 is 3 plus 3, 6 plus 4, 10 plus 5, 15 plus 6 is 21, divided by 6, that gives us 3.5. Or you can present it in this way using the histogram. So we can see and we can picture out how does the mean represents on the data, as well how does it behave, how does the data behaves based on the mean. So if you have 1 and 3, that's 4, and then 4 plus 6, that's 10, and then 3 plus 4, that's 7. Now, let's talk about first the variance. What is variance? Before we're going to proceed discussing about the histogram. The variance for a random variable of a probability distribution is, this is the symbol for the variance. Okay? This is actually the Greek lowercase letter. Is equal to the summation of x squared times p of x minus the mean squared, or the squared mean. So we have here the outcome. So for a moment, so this is now the formula for the variance, and with the mean is equal to 3.5, find the variance using the formula. So we get the variance is equal to the summation of 1 squared. Using this formula, is square the x, the variable, then multiply it with its probability. So we get like this one. And then afterwards, we are going to simplify the summation of this after squaring and then multiplying. And then we have 15.17. And then minus the square of 3.5 is 12.2. So the answer is 2.92. This is now the variance. Okay, and 2.92 is quite near to 3. Okay, let's take a look at this one. Okay, for a moment. So the population mean, the mean is 3.5, the variance is 2.92, which is similar to or approximately equal to 3. So if we have this presentation, okay, if you have here 1 plus 3, that is 4, 4 plus 6, that is 10, based on the mean, and this one is 7, that for 3 plus 4 is 7, then 10 minus 7 is 3, then 7 minus 4 is 3. So that is how we are going to look at the variance based on this histogram. Okay, so this implies, okay, let's have another example, but this time, okay, let's have an example 2. Okay, we're done with this. Example 2. Okay, we have the histogram. Another example. So we have here example 2. We have these values of our x. This is the probability on the y-axis, and then we're going to look at this way. So based on this histogram, the mean is 6. Okay, here the mean is 6 and the variance is 5. So you are going to take a look at this one. This is 2. This is 2 plus 5, that gives us 7. Here this is 7 plus 10, we have 17. Okay, then here you get 7 to 17. Our variance is 5. So from 17 to 17 minus 5, that's 12 here. 12 minus 7, that's 5. So it means this is how the variance looks like if you have to express it in histogram. This is how the mean and the variance are being featured or being shown using the histogram. It means that the distance of the element from the mean in either direction is 5, which describes the spread of the elements in the observation, and that is the variance, which is equal to 5. So this is the distance from the mean. This is 5, either to the left or to the right. Now let's have an example 3. Find the expected value of the given discrete probability distribution using the formula. So we have here the outcome is 0, 1, 2, 3, 4. You have the probabilities corresponding. 0 is 0.44, 1 is 0.36, 2 is 0.15, 3 is 0.04, 4 is 0.01. So the mean is, this is how you're going to solve. You have the summation of x times px. So you will have 0 times 0.44 plus 1 times 0.36 plus 2 times 0.15 plus 3 times 0.04 plus 4 times 0.01, and the answer is 0.82. Now find the variance using the formula. So we already solved the mean. So now we are going to solve the variance using the formula. So the variance would be, this is now the formula. So that is the summation of 0 squared times 0.44 plus 1 squared times 0.36 plus 2 squared times 0.15 plus 3 squared times 0.04 plus 4 squared times 0.01. It should be 4 squared, by the way. Minus 0. Let's make a correction for a moment. Okay, this should be squared. Then minus 0.82 quantity squared. Then we have the variance is 0 plus 0.36 plus 0.6 plus 0.04, then minus 0.6724, and the variance is 0.6879. Okay. So find the mean and variance in choosing a fair die. So this is now the answer in this finding the variance formula. Now let's proceed. You get more to solve. Find the mean and variance in tossing a fair coin twice. So placing a fair coin twice, your outcomes are 0, 1, 2. And for 0, so you got this. The probability of 0 is 0.25, somewhere here. Probability where 1 of random variable x, which is 1, is 0.5, or 2, that's 2 over 4 actually, or that's 0.5. Then the random variable 2, the probability is 0.25. So this is now the histogram. So I want you to try answering on your math activity notebook on how you are going to present the mean and variance in tossing a fair coin twice. Okay? You're going to present it in a histogram. Okay. You're going to solve it using the histogram as well as the using the formula that I have just presented. Okay, so this is, aside from the generalization and evaluation, you're going to answer this one. Okay. Then for the applications, Investors use mean variance analysis to make investment decisions. So you might be wondering, where can we apply the variance analysis, the mean variance analysis? So these are sample applications. So investors use mean variance analysis to make investment decisions. Investors weigh how much risk they are willing to take on in exchange for different levels of reward. The mean variance analysis allows investors to find the biggest reward at a given level of risk or the least risk at a given level of return. Now, generalization. As shown in the illustration below, discuss in a paragraph form how mean and variance is illustrated. So you're going to explain this one, how mean and variance is illustrated based on the histogram. Then evaluation. Given the probability distribution table below, illustrate the mean and variance using the formula and by illustrating through a histogram. Okay, so you will be answering that on your math activity notebook. Okay, so I hope that you learned from our day 2, and your assignment will be, you will just be answering the following. How do you describe a discrete random variable? How do you describe a continuous random variable? But you know this already, but just simply just recall and write your answers in your math activity notebook. Now let us proceed to the last discussion. Okay, this is day 3 and 4. So at the end of the lesson, you are expected to recall the following definitions: random variable, discrete random variable, and continuous random variable. Under the skill, you have compute probabilities corresponding to a given random variable. And under affective domain, appreciate the use of computing probabilities corresponding on a given random variable and the use of the computing probabilities corresponding on a given random variable. So computation and probabilities corresponding to a given random variable. First, so then you have to familiarize the steps in calculating the mean and variance of discrete random variable. Afterwards, calculate the mean and variance of a discrete random variable. Then develop appreciation of the uses and importance of calculating the mean and variance of discrete random variable. So let us proceed to calculating mean and variance of discrete random variable. So, recall the illustrating the mean and variance of discrete random variable. We're done with this formula. Okay? So we'll just be having an application later on. So we'll have, this is the mean summation of x times p of x. This is our variance formula. Summation of x squared times p of x minus your mean squared. Or you can use the alternative formula. You have the variance is equal to the summation of x minus mean quantity squared times p of x. Okay, there are steps in calculating the mean. The first step is construct the probability distribution for the random variable. Step 2, multiply the value of the random variable x by the corresponding probability. Step 3, add the results obtained in step 2. Then results obtained is the mean of the probability distribution. Okay, let's have an example. So construct a probability distribution if we let x, random variable, be the number of boys in the family with 3 children. The listing of possible outcomes will be like this: boy, boy, boy. Then you will have boy, boy, girl, boy, girl, boy, boy, girl, girl, and girl, 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 boy, then girl, boy, girl, and you will have girl, boy, boy. Then construct the probability distribution for the random variable from the list of the possible outcomes. So you will have 0, 1, 2, 3. Okay. So since we have the random variable x is the number of boys. So for 0, if this is 3 girls, then there's the outcome is 0. Then there's only 1 over 8 because there are 8 outcomes. Okay, where 1 boy, we have got 3. This one, 2, then 3. So you have 3 over 8. We got 2 boys. This is 1, 2, and 3. So you have 3 over 8. And we got 3 boys. We have this one, 1 over 8. Okay, let's continue. Calculate the mean. To calculate the mean, so we have this formula. Summation of x times p of x is equal to 12 over 8. Okay, that is 3 plus 6 is 9 plus 3 is 12 over 8. 12 divided by 8 is 3 over 2, that is equal to 1.5. Okay. Now, steps in calculating the variance. So, find the mean of the probability distribution. Second, subtract the mean from each value of the random variable x. Third, square the results obtained in step 2. Fourth, multiply the results obtained in step 3 by the corresponding probability. Then fifth, get the sum of the results obtained in step 4. Now, using the formula, let us use the example for in calculating the variance. In using this formula in calculating the variance, we have here is the formula, or you can use either, by the way, either of this formula. The result will be the same. So let us proceed to step. Given using the alternative formula. Okay, for a moment. So we have here the mean is 3 over 2, and the summation given mean is 3 over 2. So we have the formula for the variance. Solving the variance, we have the summation of, okay, let's go back to the given, which is 3 over 2 is the mean, and summation of x squared times p of x is equal to 3. So you got that. And then solving for the variance, we have this formula. Variance is equal to the summation of x, the quantity of x squared times p of x minus the mean squared, or squared mean. So you will have here 3 minus, because you already have here the answer, which is 3. You have 3 minus 3 over 2 quantity squared. That gives us variance is equal to 3 minus 9 over 4. Then we have 3 over 4 is equal to 3 minus 9 over 4 is 3/4, or 0.75. Okay. So we have that variance. So we got it here. This is, if using the alternative formula, you will have this one, the x squared, as well as this one, the x squared times p of x. Okay, if we're going to use the original, the first formula, we will just end up here. But if we're going to use the alternative one, we can extend our table, add 2 more rows on the table, and fill it out, and then have this data. So example, the probability that a customer will buy 1, 2, 3, 4, or 5 items in a grocery store are 3 over 10, 1 over 10, 1 over 10, 2 over 10, and 3 over 10 respectively. What is the average number of items that a customer will buy? Then calculate the variance and standard deviation of the probability distribution. Now the answer would be, you have to calculate the average number of items the customer will buy. So, hence the average number of items that the customer will buy is the summation of x times p of x. That gives us 31 over 10. Okay? 31 over 10. So you will have 3 over 10 times plus 2 over 10 plus 3 over 10 plus 8 over 10 plus 15 over 10. That gives us 31 over 10. That is equal to 3.1. So that is now our mean. Then calculating the variance using the formula. Okay, using the formula, we have the variance is equal to the summation of the quantity of x minus the mean squared times p of x. So the number of items is here, the probability for p of x. Then you multiply x times p of x. You have it here. And you have the solution for the mean. And you have your x minus mean. You are familiar with solving the variance and mean absolute deviation. The variance, we're done discussing this in our previous videos, so this is familiar to you. So you will have x minus the mean, 1 minus 3.1, that is negative 2.1. 2 minus 3.1 is equal to negative 1.1. 3 minus 3.1, that is equal to negative 0.1. Then 4 minus 3.1 is equal to 0.9. 5 minus 3.1 is equal to 1.9. Then you square the answer. That gives us 4.41, 1.21, 0.01, 0.81, and 3.61. After which, we multiply the squared result to your p of x here. So 4.41 times 3 over 10, that is 1.323. And 1.21 times 1 over 10, this one is 0.121. Then 0.01 times p of x is 1 over 10 is 0.001. Then 0.81 times 2 over 10 is 0.162. Then 3.61 times 3 over 10 is 1.083. So the answer is 2.69. Okay, and then if you're going to get the standard deviation, this is our variance. But if we're going to get the standard deviation, this is the one is equal to 1.64. Okay, but the variance is 2.69. Okay, let's continue. So let's have an application. So what do you think is the application of random variables? Okay. Now the use of random variables is most common in probability and statistics, where they are used to quantify outcomes of random occurrences. Like risk analysts use random variables to estimate the probability of an adverse event occurring. Okay, let's continue. So let's have the generalization. So what are the steps in calculating the mean, variance, and standard deviation of discrete random variable? You're going to answer this in your math activity notebook. Then how do you apply the important concepts of mean and variance of a discrete random variable? Okay, now let us proceed to evaluation. So still you are going to answer this in your activity notebook. The problem goes this way. A certain university medical research center finds out that treatment of skin cancer by the use of chemotherapy has a success rate of 70%. Suppose 5 patients are treated with chemotherapy. The probability distribution of X successful cures of the 5 patients is given in the table below. You have X, 0, 1, 2, 3, 4, 5. These are the probabilities. For 0, you have 0.002. For 1, 0.029. For 2, 0.132. And 3, 0.309. 4 is 0.360. And 5 is 0.168. This is the probability distribution of cancer cures of 5 patients. You are going to find the following: the mean and variance. Okay. Then, number 2. Consider the example of the number of languages spoken by Filipino school children. Define X to be the number of languages in which a randomly chosen Filipino child attending school can hold an everyday conversation. Assume that the probability function of X, P of X, is shown in the following table. So you got here X 1, 2, 3, 4, 5, 6, and then P of X is 0.663. Then For 2, 0.226. 3 is 0.066. For x is 4, 0.022. X is 5, 0.019. And x is 6 is 0.004 as the probability. The letter A question, letter A, what is the mean of x? Then, or what is the mean of this random variable x? Then letter B is find the variance of this random variable x. Okay. In your assignment, memorize the formula in calculating the mean and variance of discrete random variable. Okay. So I hope that you learned in our entire week video lesson. This is week number 2. And to end this video, by the way, thank you so much for all the subscribers again, and please don't skip ad within my videos, or in between or before my video lesson. That will help me to continue making more videos. And to end this video, let's have a quote. A man is like a fraction whose numerator is what he is and whose denominator is what he thinks of himself. The larger the denominator, the smaller the fraction. So it boils down with humility. So bottom line, we have to be humble all the time. So thank you so much for watching, and again, please don't forget to subscribe my channel if you are new to my channel, and please hit like and feel free to write your comments below. Thank you, and God bless us all. Bye.